Problem number 5. Draw the isometric view of a hexagonal pyramid of base height 30 mm and height 70 mm. Rest on its base on HP with the base edge parallel to VP. Base edge parallel to VP. Resting on HP. It is cut by a plane perpendicular to VP. Cutting plane perpendicular to VP. Therefore, VT. And inclined 45 degree to HP, meeting the axis at a point 40 mm from the base. So we have to draw isometric view only. We can use ordinary scale. Step 1 is to draw the simple front view and top view of the given object. So we draw a reference line. We draw the top view first. Hexagonal pyramid of base height 30 mm, base edge parallel to VP. Therefore, we draw 130 mm base edge parallel to VP. We draw a hexagon in such a way that one of its base edge parallel to VP. So, we take 30 mm here, because the included angle of the hexagon is 120. So we take 30 mm from the vertical. Similarly, here also we take 30 mm from the vertical. So draw this, draw one line. Yes, so we draw like this. We draw another line like this. So here is a 30 degree line. We put this onto the 30 degree line. We take this measurement, take this height, we take this base side, and then this base side has to come here. Again, this base side has to come to the next side. Draw the height that we have here is very much useful. So we take this height and make use of this height here. Similarly, we can draw this height. Thereby, we can construct the hexagon, get the hexagon in the given position. So here also we make use of this line. We draw the hexagon. Draw the hexagon like this. Then yes, so now this 30 mm should be divided into two equal parts, so that we can find the axis of the prism, axis of the pyramid. And finally we can join the respective center, so that the top view of the pyramid is complete. We have this. Similarly, we can join this with the other side. Then this can be joined with the bottom side and so on. Now that we can project this, this is the solid in simple position. Given the height of the pyramid, so we can make use of this axis, and it's given the height of the pyramid is 70 mm. So what we do, we take 70 mm here, 1 2 3 4 5 6 7. So we take 70 mm here. So we name it as O dash, front view, top view. We name this as A, B, C, D, E, F. So therefore we have A dash here, then B dash here, A dash, B dash, then C dash, and D dash not visible, E dash not visible, then F dash, right? So now C dash is one edge, O dash, C dash is one edge, again O dash, B dash, O dash, E dash is another edge, O dash, this is another edge, then we connect O dash, A dash. The given solid is a truncated solid, therefore we have to introduce the cutting plane also. So we join this O dash, F dash. Now that there is a cutting plane perpendicular to VP and inclined 45 degree to the HP, meeting the axis at 40 mm from the base. So we take 40 mm from the base, we take 40 mm from the base and locate the cutting plane 1 2 3 4, that is this point. Check the cutting plane. From here we take, so the given cutting plane is inclined 45 degree. We draw the cutting plane inclined 45 degree to the HP, perpendicular to VP. Now the cutting plane is drawn, we name it as VT. The inclination is given as 45 degree. This is 45 degree, and the cutting plane 40 mm from the base. Cutting plane meets the axis at a distance of 40 mm from the base. Height of the object is, height of the pyramid is given as 70 mm. Height is 70 mm. Then the base side is given as, the base side is given as 30 mm. So we take 30 mm here. Now we have to plot the point on the cutting plane. We take the first generator O dash and F dash, and the point on the cutting plane as 1 dash, and in the second generator O dash and A dash we mark it as 2 dash. Similarly, in the third generator, the point is marked as O dash, B dash is 3 dash. Point between O dash and C dash is termed as 4 dash. Similarly, point between O dash and D dash is termed as 5 dash. Point between O dash and E dash is termed as 6 dash. So these are the 6 points on the cutting plane. Now O dash is between 1 dash is between O dash and F dash. Therefore 1 lies between O and F. 1 lies between O and F. Similarly, 2 dash is between O dash and A dash. Therefore 2 lies between O and A. We just project and we find out the intersection of O and A. We name it as 2. Similarly, 3 dash is between O dash and B dash. So naturally 3 lies between O and B. So we call it as 3. Again, C dash, between C dash and O dash we have 4 dash. So therefore between C and O we have 4. So we project and we find out this point as 4. Similarly, between O and D we have 5, because between O dash and D dash we have 5 dash. So between O and D we name this point as 5. Between O and E we name this point as 6. So now we join these points. We get 1, 2, 2, 3, 3, 4, 3, 4, like this. Similarly, 5 and 6 can be joined. 5 and 6 can be joined, and we can join 1 and 6 as well. 1 and 6. So this is there. So therefore the remainder is very simple. We have to join this, then we have to join this once again. A and 2, F and 1, then E and 6 to be joined, E and 6 to be joined, 5 and D. Again, all the outer edges must be drawn dark. We draw it. We draw this. AB is drawn dark. You have to draw this AF dark. Again, EF should be drawn dark. EF should be drawn dark, and DE should be drawn dark. Now rectangle. So we draw a rectangle so that we can draw this rectangle and offset the hexagon very easily onto the rectangle, right? So the rectangle what we draw is ABCD. So we put P, Q, R and S for rectangle. So we start we use a baseline, then we have a starting point. We take 30 degree on either side, first side 30, the other side 30. So now we are going to draw the box and we are going to offset the various. Since we are practicing isometric view, we need not draw isometric scale. You have to draw isometric scale only when we draw the isometric projection. So we draw this is front view. Right, now we take this box. This box has got a length of this much. Yes, it has got a length this much, and it has got a breadth this much. Various. So we draw a line through this to represent the length. Represent the breadth. Now that here is 1 dash at the down and 4 dash at the up. So we always put the one which is at a smaller height in the front end and the one which is at a larger height at the rear end. So therefore we plan our diagram in such a way that we get one somewhere in this side. Okay, so we have P here, capital P, and S here, PS here. So you get Q here, then you get R here. This is how we have planned. So we can name the shapes accordingly. Between P and Q we have P and Q. We offset this and find out the point A, and when we offset from the other side we can get the point B. So here is point A, this is point A, and this is point B. B and S we take F. So mid of P and S gives us F. So this is nothing but F. Nothing but F. Afterwards we have this. So naturally when we draw any line through F, will get us C. So we get C by drawing lines. We draw a line through A, we draw a line through A, we certainly get E. So E is obtained by drawing a line through A. Similarly, when we draw a line through B, we get D. Now we plotted A, B, C, D, E, F. We are supposed to find out 1, 2, 3, 4, 5 and 6. So now we have the location of 1 which is exactly at the center line. So now we find out the center F. So on F line we take this small distance and we offset. On the F line we take this small distance we take this small distance, and on the F line we offset this. This is the location, and we have to give the height. So we draw the height line through this, and we take the height line from the front view. So this is the height of 1. So we take this, and when we cut it here, we could get 1. So 1 is obtained. We have taken the location of 1 in the top view. We place that in the top view, and we have taken the height of 1 in the front view, and when we place it on the height, we are able to get 1. Similarly, we can find out the location of 2. Location of 2 is obtained by taking this distances. So what we do, we take the distance of 2 in the top view as from P to Q. There is a distance. We place it from P to Q. We place that distance. Finally, on the breadth line, we have this distance. So that distance is from P to S. So therefore, from P to S, we mark this. Then we can find out the location. So when we join these two lines, a line through this, a line through this, a line through this, then 2 can be obtained. So now, with the help of this location, we are supposed to add the height. So when we add the height on this, we are supposed to refer the front view for height. So we go to the front view, and we refer the height for the point 2, which is nothing but the height for point 6 also. So the respective point 2 is obtained. So point 2 is known now. So we got 1. How do we get 1? 1 is from the F line, midline, this length and this height. So we are able to get 1. Similarly for 2, we take from P to Q, there is a distance. So we offset from P to Q distance, and P to S distance. Yes, P to S distance. This intersection gives us the top location. Then the height of 2 is taken from the front view, and it is placed. We are able to get 0.2. Similarly, we can take the location of 3 as well. 3 is there. So here is 3. 3 is available, and this length and breadth location of 3 can be obtained. So what we take, from Q, we locate this distance towards P. From Q towards P, the distance is located. Afterwards, from Q towards R, the distance is located. From Q to R, the distance is located. So therefore, this length and breadth on the QR line and QP line gives the location of point 3. This is on the QR line. We take the other line, we find out this. Finally, we are able to get the location and when we add the height, the exact 3 can be obtained. So this location is known. When we add the height, we get the exact 3. So the height of 3 is obtained from the respective front view. So we take this and we find out the height of 3, which is supposed to be the height of 5 also. So height of 3 gives us the 0.3. So we have 0.3 location. Similarly, we can go for 0.4. 0.4 is located at a distance of C4 on the CF line. C4 on the CF line. So therefore we have C4 on the, we can very easily find out 0.4 C4 on the CF line. We can add the height for 0.4, height for 0.4, then height for 0.4 is obtained from the respective front view. Then we can find out the height. Finally, the location of 4 is obtained. So again 5 and 6 can be obtained in a similar manner. So we have the 5 location somewhere here, which is exactly on the location of this QR and RS. So we take our RQ line and place this distance. RQ line is taken and the distance is taken. Here is RQ line and the distance is taken. Then we have RQ, we have RS and the distance is taken. RS and the distance is taken. So obviously you will be able to find out the location of 5, that is location of 5 like this. Similarly, with reference to this line, we can locate 5 over here, and this has to be referred from the front view. So we take the height from the front view for 5. Height of 5 is height of 3. Height of 5 and height of 3 are remain the same. We take this height 5, then we locate height 5. We are able to locate the point 5. Similarly, we can locate point 6 also. Point 6 can be located. So here is point 5. So 3 and 5, they are on the same line. Point 6 and 2, they are on the same line. 6 and 2, they are on the same line. So location of 2 is available So we have 1 here, we have 2 here, this is location of 2. Accordingly we can locate 6 also on the same line. In the same line we can locate 6, but the distance between 2 and 6 is given like this. So we can make this distance and we can add the height also. 6 can be obtained. Point, we take this height, therefore location of 6 is very simple. This is the location of 6. The height of 6 and height of 2 remains the same. We put it on this height 6. We are able to find the point 6. Now that we have to join all the 6 points starting from 1. So this is point 1. 1 has to be joined with 2. 1 has to be joined with 2. Then 2 has to be joined with 2 should be joined with 3. 2 should be joined with 3. Then 3 should be joined with 4. 4 we join 4 and 5. We join 5 and 6. 5 and 6. Similarly we can join 1 and 6. 1 and 6 can be joined. Now we can join A and F at the bottom. AF at the bottom, AF at the bottom, and AB once again at the bottom. Then BC at the bottom, BC at the bottom. F and 1, F and 1, yes, A and 2, we join A and 2. Then we join B and 3. We join B and 3. We joined C and 4. We join C and 4. C and 4. 2 and 3 can be joined. So 3 and B to be joined. 3 and B should be joined. Then 3 and 4. Similarly C and 4 should be joined. C and 4 should be joined. And E, you have to join F and E. Again F and 1, then E and 6. You have to join E and 6. Therefore the isometric view of the truncated solid is obtained now. So what we have at the bottom, AF, FE, AB and BC. At the top we have 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. And in the respective points on the cutting plane we have F and 1, A and 2, B and 3, C and 4. Then R and 5 is to be joined by a dotted line. Then E and 6 is joined. So now that we draw this, and the base side is taken as 30 mm. This base side is taken as 30 mm. So 30 mm is given, 30 degree. This angle is 30 degree. So to start with, we just draw the hexagon in a simple position, that is, we make one side parallel to VP. Hexagon is drawn with one side parallel to VP, and we projected and we got the isosceles triangle in the front view. So accordingly, we introduce the cutting plane. The cutting plane is introduced. The cutting plane meets the axis at a distance of 40 mm from the base. Total height of the pyramid is 70 mm. Then it is drawn 45 degree inclined to the HP and perpendicular to VP. Accordingly, we got the sectional points, that is 1 dash lies between F dash and O dash, therefore 1 lies between F and O. 2 dash lies between A dash and O dash, therefore 2 lies between O and A. Similarly, 3 dash lies between O dash and B dash, therefore 3 lies between O and B. 4 dash lies between O dash and C dash, 4 lies between O and C. 5 dash lies between O dash and D dash, 5 lies between O and D. 6 dash lies between O dash and E dash, 6 lies between O and E. So now we understand, with the box enclosed on a hexagon, the box is drawn here with the base side and the length, keeping the one which is at a smaller height at the front end and one which is at the larger height at the rear end, so that the complete shape of the object will be visible. So now we have to locate the isometric view position of point 1. So location FC is taken, and this distance is specified here, and the height of 1 dash is taken and it is placed, and the point 1 is obtained. Similarly, the length of 2 and breadth of 2 is taken, and the top view of 2 is located. Length on PQ is taken, and breadth on PS is taken. So breadth on PS is taken. So combined length and breadth gives here, and the corresponding height of point 2 is taken and it is placed, and we cut point 2. Similarly, the location of 3 is obtained. The length on QP and breadth on QR. So QP length and QR breadth is taken, and we are able to locate this point. And then we add this height. So on this 3, when we add the height, we are able. Similarly, for point 4, the length on QR, that is on this line, CF line, this C4 is taken. We have taken the CF line, and we have located this on C4. C4 is taken and located. Height of 4 is added here, and we are able to locate 4. Similarly, the location of 5 breadth and 5 length is taken. 5 breadth and 5 length, that is 5 breadth on RQ line. The RQ line, 5 breadth is taken, that is this length is taken, and this one, and RS line, this length is taken. We take the RS line, this length is taken. So finally we locate the point 5, and the height of 5 is given. We locate this gap on SP. So we take SP gap, then this length inside, and we added the height of 6. 6 is taken from here, and we added finally we get the point 6. So we blindly join the points 1 2 3 4 5 6. We join 1 and 2, then 2 and 3, 3 and 4, 4 and 5, 5 and 6, then 6 and 1. Ultimately in the bottom we take the extreme points C and B, B and A and F, and F and E. E is connected with 6, F is connected with 1, A is connected with 2, B is connected with 3, C is connected with 4. So we get the truncated pyramid.